Hello everyone. Let's begin with something fascinating. Have you ever wondered how those big power stations manage to light up our homes? The secret lies in a simple but powerful idea: converting motion into electricity. The alternating current generator works exactly on this principle. It converts mechanical energy into electrical energy using electromagnetic induction. Imagine a rectangular coil with many turns placed between the north and south poles of a strong magnet. As the coil rotates, the magnetic flux through it keeps changing continuously. And here comes the magic. According to Faraday's law, whenever magnetic flux changes, an electromotive force is induced. That's how motion is turned into electricity. As you can see in the diagram of figure 6.13, the coil, slip rings, and brushes all work together to make this happen. Now, let's take a closer look at the generator's construction. Picture a rectangular coil with length L and breadth B. Its area is simply L multiplied by B. This coil is mounted on an axle and made to rotate with angular speed omega. The ends of the coil are connected to two slip rings, and carbon brushes make contact with these rings to transfer current. The magnetic field is provided by a permanent magnet with north and south poles. All these parts together, the coil, slip rings, brushes, axle, and magnets, form the heart of the generator. The annotated sketch makes it clear how beautifully simple yet ingenious the setup is. Alright, time to move into the mathematics. Suppose the coil is at an angle theta with respect to the magnetic field. The magnetic flux through the coil at that instant is equal to B times A times cosine theta, where B is the magnetic field and A is the coil area. If there are n turns, the total flux becomes N times B times A times cosine theta. Now, differentiating this flux with respect to time gives us the induced electromotive force. Since theta equals omega t, the result is induced EMF equals N times B times A times omega times sine omega t. Notice how the EMF varies sinusoidally with time, going up, down, and even changing sign. That's why it's called alternating current. From this expression, we can easily see the maximum EMF. When sine omega t equals 1, the peak EMF is N times B times A times omega. At any instant, the EMF is given by E equals E naught sine omega t, where E naught is the maximum EMF. Since sine is positive and negative, the EMF reverses direction every half cycle, giving us alternating current. And the frequency of this AC is the same as the frequency of the coil's rotation. If you look at figure 6.14, the graph of EMF against time is a perfect sine wave, smooth, symmetric, and alternating. So, what's happening energy-wise? The mechanical work done in rotating the coil is converted into electrical energy. The brushes ensure that current from the rotating coil is smoothly transferred to the external load circuit. The amount of energy generated per cycle depends on the torque applied to rotate the coil and the induced EMF. Of course, the efficiency of the generator depends on design features like the resistance of the coil, the magnetic core, and how well energy losses are minimized. That's why large power stations use carefully engineered designs for maximum output. Let's quickly solve a numerical to make things concrete. Suppose we have N equals 100 turns, magnetic field B equals 0.05 Tesla, coil area A equals 0.02 square meters, and angular speed omega equals 50 radians per second. We are asked to find the maximum electromotive force. The formula is simple: maximum EMF equals N times B times A times omega. Substituting values, we get 100 multiplied by 0.05 multiplied by 0.02 multiplied by 50. That simplifies to 5 volts. The units check out too. Weber per second equals volt. So the maximum EMF generated here is 5 volts. Let's wrap up what we've learned today. The alternating current generator works on Faraday's law of electromagnetic induction. As the coil rotates in a magnetic field, a sinusoidal EMF is induced. The instantaneous EMF is equals E naught sine omega t, and the maximum EMF depends on the number of turns, the magnetic field strength, the coil area, and the angular speed. AC generators are at the heart of modern electricity supply, from power plants to the electricity that runs your fan, fridge, and laptop right now. I hope you now see how something as simple as a rotating coil inside a magnet can literally power the world. See you in the next session, where we'll explore yet another exciting concept in physics.